Um, so the idea is that today the topic will be precompiles in the kind of context of IPs, and a little bit more general beyond that, kind of using that as because the first IP that we have brought to finalization, of course, 7.2.12, it introduces a new precompile. So talking a little bit about the process as well for finalized IPs to make it onto layer 2s, how to track that, maybe what pain points are there still? Does it even the whole idea was that the IP process with standardization should give layer 2s more confidence that implementing these features is de-risked. So basically checking in, is that so far does it feel like we're on track with that? All these kind of topics. So to get going basically with the agenda, I just wanted to very briefly kind of summarize where we are at so far. So basically we for now just copied the way EAPs work in terms of the different statuses that they can be in. So basically the final status that the last status that an IP reaches is finalized. The idea there being that at that time there are no further changes to the IP allowed, and that should give teams then confidence that if they implement that feature exactly by the spec, then all teams implement doing that will end up with the exact same version, of course. We have the as I was saying, 7 to 12 is the only IP in final for now. And then in terms of precompile specifically, you might remember we were talking with core devs on mainnet with regards to how they think about kind of avoiding collisions in terms of precompile addresses. Also making sure that if they ever want to ship a IP precompile as well, that kind of is done in a good way. And the consensus there was that we were handed a separate precompile range, so at basically addresses 256 and up, and that mainnet wants to basically wait with talking about reusing IP precompile addresses until they are ready to ship the first IP precompile themselves, which also very plausibly could be 7 to 12. So that's kind of where we're at currently with precompiles. And then of course there are a few interesting questions we can get into in this call. But I thought might be a good idea to start by having someone from the Play team, from the 7 to 12 authors, briefly kind of summarize basically what has happened since finalization. So
Sure, thanks for the intro. I guess for now there are 3 rollups that are committed to implement the RIP, and they also started implementation in their code base. The first one was the Polygon site. They requested a Polygon improvement proposal, and we have prepared it. It's PIP 27. Then we have discussed it in a few of the community calls. Then they have included the proposal in their next hard fork. It's Napoli hard fork. I guess the testnet release was this week, and the mainnet release should be the following weeks. And the next one is the casing. They are ready in the implementation of the precompile and its circuits, but it's waiting the next VM upgrade, and they say that it might be in this April, and the circuits and all requirements for the precompile is done, but we are waiting the next VM upgrade in their side. And also the Optimism team started their implementation in their code base. There's a draft PR in the code base. I think it's also ready, and scheduled for one of the next hard forks. It's, I guess, Fjord hard fork. I hope I'm not missing any of the rollups. And I have seen that the Elmos has done an implementation in the Cosmos side.
Okay, yeah, thank you. I guess it also already brings us out for now. This time I only have a few kind of parts that I prepared on the open section, on the open questions section, then we can go to open discussion. But one of those specifically, I think fits very well here, and that's kind of the question of how to keep track of implementation status in L2s once an IP reaches final. Of course, the question is how frequent do we want to be there? I don't think it makes sense to necessarily distinguish between interest and then commitment and whatnot. But like at some point, basically, we have to indicate, okay, this is about to be shipped, and then this is now live on a specific L2. And Carl, I think we talked about this briefly. Could you briefly kind of summarize kind of our thinking so far and kind of the idea for tracking we had?
Yeah, I mean, basically, it would be nice as a developer who's wanting to deploy a contract to multiple L2s to be able to have a single place they can know whether they can use a feature, and have like better oversight if they should ship something that supports a precompile or not, that kind of thing. And so the idea is that as a part of the RIP repo, we can also have a small registry which basically only contains finalized RIPs, and when they are finalized, that we can show who has implemented what. Exactly what's in there and how that is formatted is still something that's kind of open. Currently, I just have a little JSON file, but it's very empty because it's one RIP and no one has shipped it to mainnet yet. And so the status that is not super helpful. But as Ulas was pointing out, we already have many implementations of this, and I see in the chat there's some more. So it would be nice to have insight into that with reasonable ease. And so that's hopefully what this will be. And then as it gets shipped from L2 sites, everyone's welcome to just make PRs to add themselves to this registry of, hey, we've shipped it. But again, it's only if you have like exactly implemented said RIP as per the specs.
Awesome. You said you already created that file. Is it already in the repo, so we could link it, or if there's a PR or something?
I'll drop a link in the. I'll drop a link in the chat. It's a branch. I'll open the PR today. But yeah,
just for people to take a look and see.
Absolutely.
Yeah, how that will look like. Awesome.
I have a question.
Yes.
How should be the decision of which chains or rollups should be included in this registry?
I mean, I think that's going to be one of the most difficult questions of the whole roll call and RIPS process in general. The idea is basically if you're in the greater ecosystem and you're like vaguely look like a rollup, then I think the answer is going to include you. So sort of default inclusion as to exclusion. And for some things where, I mean, even if, for example, RIPs start getting shipped on other EVM chains, not necessarily L2s, I would even consider including that in there. So yeah, in general, just default inclusion as opposed to exclusion, up to the point where it starts becoming too noisy to interpret. The point of this process is not to like define who is and isn't a rollup slash L2, but more just to be a useful resource.
Right. One question that I would have, maybe briefly on this point, or not the point of who's in the L2 that maybe we don't want to talk about, but in terms of tracking which L2s have shipped this, of course, on the EIP side, we have like this somewhat fine-grained the difference between draft and then review and final call before we get to final. So is there any use, like would people here think that they would basically be used to for tracking, starting to track basically as L2s start to either consider shipping in IP, or like say once they have made that decision but are still in the process of implementing it and bringing it to the L2. So is that too fine grained, and basically it only makes sense to track once it goes live.
My personal stance on this is that it's too fine-grained. Just that there's a lot of status changes and many different levels of staging, and I think it becomes something that would need to be policed a lot more, or just have a bunch of attention paid to it. Whereas if it's just like, is this on mainnet? I think that's much easier. I guess one exception, like a weaker form of this would be, is it on a testnet? And then we can include testnets as a separate thing, which I would be open to. I guess the question becomes who we're trying to serve with this, because I feel like testnets are mostly used internal to all the various rollups as opposed to mainnets which are external. But maybe I'm mistaken in that.
Yep, sounds reasonable. We have a question in chat. Elias is asking, but there's basically something equivalent to the kind of the test suite that we have for mainnet EVM for this IP. So of course, this is the first time we kind of have some standardization around a feature that's not equivalent to what we do on mainnet. So I personally haven't kind of thought about this much yet, and I think that's a really good question. I don't know. I see we have Ari on the call. Of course, you're a bit more on the DevOps side. I don't know. Is there, how close are you to testing? Could you briefly talk about maybe what it would take for features like that? I mean, I don't know. I don't want to put you on the spot, but if you have thoughts on this, maybe.
Yeah, could you just repeat the question one more time? Sorry.
Of course. So it's basically the question from chat. So of course we have Ethereum tests for EIPs and for changes to the mainnet EVM. How open would that be to basically adding as the canonical place to also have IP tests? Or is it something where your intuition would be that we would need our own testing suite for non-mainnet, for IPs basically?
I'm not sure if we should add it in the same place, but definitely could probably fork the repo and implement whatever that needs to be done in the fork. I think that's probably an easier way to go. Especially, I haven't gotten deep into the L2 world yet. Is most of the testing happening with just are we talking about the spec tests or Hive or testnets, or which layer of testing are we talking about?
Yeah, maybe Elias, if you wrote the comment, if do you have some perspective on kind of how you on the L2 side think about testing, or?
I'm not sure. It's just as like rollups maintain compatibility but add new features and like eagerly implement new EIPs. I wonder what's the best way to validate that everyone has a like consistent implementation. I would imagine that, I mean, it would sound reasonable to like add these tests in the Ethereum test repo under like a specific folder such as, I don't know, rollups or prospective EIPs. Mainly because all the logic for like has been implemented, like the runner and so on, and they do extensive precompiles tests. Mainly also because I don't know how we would do it otherwise. I mean, the fork sounds reasonable, but then we have to rebase every time. But I guess it's an implementation detail.
Got it. I think there'll be like one or two things. So the first one would be generating the tests themselves. I think the test execution tool in question would then be retest ETH. And I guess for that one, it does make sense to probably fork that and support it. The higher level test part is Hive, which usually takes in an expected input, expected output, and then asserts what's going on. And I think that would also probably make sense as a fork, because then you can add the definitions for all the layer 2s in there, and any change in the definitions of an EL in the L1 wouldn't affect you guys. So it probably does make sense to, like you said, it's an implementation detail, but I think most of the infrastructure is built such that you can fork it and probably continue supporting the same thing, but for rollups.
That sounds reasonable. But for example, for Kakarot, we don't use RS tests. I don't know how to pronounce it. The runner for the EF test, we have a custom runner, but we still use all the JSON and all the, as you said, the pre-state and post-state assertions. So even this kind of standardization is somewhat has a, I mean, differences.
I would recommend not using retestf and using either that custom format or looking at the execution test specs, so that the real output is the test file, not necessarily the fillers. And that's just because from core devs, we're looking at trying to get rid of retestf and just use the execution tests. So retestf might not get maintained much longer.
How about just then the execution test, the JSON files that have the pre and post assertions?
I mean, that's ultimately what test harnesses will consume. So however we get there is fine. You could have a custom program that outputs it as long as it's repeatable and verifiable. And if we're doing something like verifying not just the layout of like a precompile call, but the actual math behind it, backing those tests by an implementation that is the quote unquote reference implementation would be great. And we could use, like, if it's in Python or C or whatever, to generate test vectors from that. That I think would be fine. I don't think we need to obsess with creating retestf quality fillers, as long as we have some way to regenerate them and can verify what each step means.
I definitely think having Mario on one of these calls would probably help there, because he's also looking at how to best move away from retest ETH and where execution spec tests, etc., fits in perfectly. And additionally, he's been thinking of how to set up this whole workflow for verbal tests, where there are quite a few things that are drastically different from how things happen right now, and probably inheriting that same logic for RIPs would make sense.
Yeah. On the last call, there was like a discussion about fees. And so I was just wondering, what if different rollups, when they implemented certain RIP, for instance, this one, like of a precompile, they have different costs for it. Will that still be considered as supported precompile or not? And if it will be, then I'm not exactly sure whether ETH tests will work, because if I recall correctly, though I've never worked closely with them, I think they would require fully gas equivalent behavior to work correctly.
Right. So for now, this is actually a really good question. But for now, we still basically do the lazy thing where the IPs fully specifies all behavior, including the exact gas pricing. And so if LL2 would be uncomfortable with that gas pricing, then that would technically not count as shipping the same IP. And then I think it would be a really good conversation to have. Like, what do we do in these cases? technically kind of if there was any other type of behavior change, what we would recommend is just shipping it at a different address because it's a slightly different precompile. Of course, for pricing, that's what we talked about last call. In principle, we would want to get to a world where you could have the same features and just different pricing. We just don't have a system for that yet. So if there's an L2 right now, for example, that does consider doing that with L1, then I think there would be an interesting conversation to have whether to still ship that at the same address or not, and then how to keep track of that is a modified version. But in general, with maybe the exception of gas pricing, the idea would be that modified versions should be shipped at different addresses because because they're not quite identical.
I think maybe a way to solve this is if the RIP for each precompile specifies the maximum cost, the one that is that no one would be charging more, and then others can have a refund mechanism at the end of the transaction, just like when refunding on other things. And this way, the code is not disrupted by the different pricing, but they can still make it cheaper on their rollup if they're able to sustain it.
And how would we pick the highest price? Oh, sorry.
Sorry?
How would we pick the max price?
Yeah, this has to be agreed by everyone. That no one thinks that it needs to be more expensive in order to be sustainable on their chain, and then other chains that can make it cheaper can just have a post-transaction refund. It's not ideal, but we should be able to reach like a certain price that no one thinks that it should cost more. Wouldn't it be possible? Okay, I mean, no one would say that it has to be more expensive than, I'm taking it to extreme. No one would say that it's more expensive than an EVM implementation of the same functionality, right?
I think like some ZKs would want it. For example, like if Kachek were precompiled, they'd absolutely want to jack the price up.
Oh, right, yes. Okay, yes, so you're right. Maybe refund is not sufficient here. So maybe we will need a separate address, like a different address for this. But it kind of negates the value of having an RIP to begin with.
So I'd like to add 2 points to this. First, we've changed the price of precompile on mainnet before. ModiXP has had 2 different versions, and it's even got issues depending upon how you implement it, whether or not how you handle your even moduluses. But I think that's a second issue in that I think we should seriously consider mechanisms to disconnect the gas schedule from the EVM execution, and that would include precompiles. Because with ZKs, for example, there might be EVMs that are more efficient on some operations, some that are less efficient. They might want to distinguish themselves by gas schedule. And as we've learned in the past, when we had to manipulate the gas schedule for things like storage, it's broken contracts before, and it's already a recommendation among auditors never to depend on specific gas costs. So I really think we should get in a direction where the gas cost is separated from the actual execution of the precompile.
Yeah,
I think you go ahead.
Right. I'm not sure, Daniel, were you on last week's call when we talked about fee markets?
I had another call that I couldn't make at the same time. But
no worries.
Yeah.
Yeah, so basically we also talked a little about that, and indeed kind of I also brought up EOF as of course a way to remove gas observability, and then especially say I could in the future imagine that there might be L2s that only support EOF mandatory. And in that world, it would be much easier to then indeed kind of disconnect the specific gas schedule from the EVM implementation. And yes, and that was mentioned as one there's desirable outcome. I also separately, like my takeaway from last week's call was that this is for most teams this is lower priority, even on the ZK side. People, while a little grumbling about different kind of efficiencies of different precompiles and whatnot, for now are fine with making it work. The more principled approach in general for specifically for say ZK proving would be to basically introduce a way to just have kind of like a multidimensional fee market that could basically give precompiles an extra kind of prover gas cost or something. But in either of these cases, basically, whether we do the very simple, just agree on a maximum, whether we have remove gas observability and we basically get to a world where you can just do more free repricing in general, or we do like multi-dimensional pricing or some mix of those. And none of those are basically in a point right now where they can be shipped, right? And so basically, if we talk about, say, where are we at with the R1 precompile and whatnot, the idea is basically for now, within the standardization process, we would have to stick with exactly agreed upon fees, and then this is basically something to follow up on now as a research process of how do we then move to a better and more principled world that allows more freedom for those that incur different costs. Yes. So that's kind of like I think one of the takeaways here that needs active research. And then to follow up on the computational testing side as well. This is a similar situation. I just wasn't aware, like and kind of testing was not on my radar as a topic for today. Otherwise we could have invited some testing people as well. But I think this is a really important topic that we should definitely follow up on a future breakout call maybe. And in particular, I think it is a question that will become more relevant as we have more IIPs that reach final. And as we have this distinction, like the R1 precompile, we might bring to mainnet. So I would over time expect it to be implemented in all the mainnet EVM clients, and then over time also just be part of even the mainnet testing suite and everything. But there might well be IIPs in the future that just never get support in the upstream clients themselves and whatnot. So I think basically testing is a part of a broader question around how do we think about support in all the levels of the stack, right? And all the different tooling, the different clients, testing everywhere. Like, how do we kind of maintain proper standardized support across all of these if they're no longer just, we don't get them for free because all the mainnet tooling just implements that by default. So I think that's definitely a question that deserves its own breakout call. So yeah, it was good to see that come up as well. Do we have anything further on that kind of general set of topics that might make sense to talk about now?
I just had one question about EOF, because we mentioned it as probably not the magic solution, but a good solution to remove gas from like the applicative layer. And I wonder if anyone here that we know has like started implementing it for rollups and like what it would look like. Because as I understand what you mentioned, EOF would remove the need to standardize gas cost between rollups, like for EIPs or just in general gas pricing. But maybe I misunderstood this from last call.
So EOF is a candidate for Prague, the Q3, Q4 release. They haven't finalized scope. It might be out, it might be in. I'm pushing for it to be in. Besu's got, we're working on final implementation of it. But when Geth gets an implementation, a lot of the rollups are Geth derivatives. So it's just going to be an issue of just updating the code. And it works parallel with the other EVMs. It's actually just a container format for the EVM. It's still the same underneath it. So for rollups to get it, they would just need to update the Geth code or do significant changes to the Geth code to bring it in early. But I'm not aware that any implementations have seriously gone down the path of multiple schedules between the two. So a lot of gas schedule divergence just hasn't happened yet.
As I understand it, it's like not retro compatible, right? Or like it removes a lot of, like it removes the gas introspection from the code, no? From the
So the container itself, so it's the EVM would run both legacy or EOF. You could probably configure it to say only EOF is accepted. But as far as code that is tagged as EOF, you don't have access to the opcodes that would allow you to do introspection for gas or allow you to do introspection for code. Now, the legacy stuff that you could call into could also do that, just not through delegate. So in a way, you could say that EOF, it's not backwards compatible to do those if you're going to go forward with EOF. And the only way a chain won't be able to do those is if the chain is entirely EOF. Otherwise, you could call into a legacy contract and do gas introspection and your code introspection in the legacy code. So it's kind of like, ring 0, ring 1 stuff in Intel, probably a better way to think about it.
Okay, because Kakarot is still not in testnet, but probably mainnet is like within a year. It would make sense to directly leapfrog to EOF then, but then kind of like alone in this state of EOF only chain.
I'm a huge advocate of EOF only chains. I have dreams about that.
That would be good, right?
Yes, there's a long list of things I think would be awesome.
Okay.
Well, of course, just to mention that, right? Like, because I agree that for the researchers, right, and from that point of view, it would be amazing to see that. For the chain themselves, you do have to take into account that if you were to launch as EOF only, and this is already assuming we ship it to mainnet, so that in general it's broadly supported. If we don't end up shipping into mainnet, then I think it'll be more of an opinionated decision anyway, because then you have to kind of you'll have to rely on somewhat less broad support in the ecosystem. But even in the case of that it already went live on mainnet, launching EOF only means that a lot of projects that have already written their contracts not using EOF would have to actively move on to newer versions using EOF before they could be deployed. So it is a not very opinionated choice. And I agree, I would also love to see this, but I just want to flag it because otherwise you might run into issues down the road. And just to very briefly clarify, how does this relate to changes? I think that Daniel, you already mentioned that. Of course, the point is that even if you are on a chain that has both EOF and legacy code that can do gas introspection, or even if you're on a chain that does not ship EOF at all and you only have legacy code, and so all code can do gas introspection. The point is not that moving away from the mainnet gas schedule necessarily is impossible or breaks anything if we are in that world. It is just that contracts might have been written in a way inadvertently violating best practices of not relying on gas pricing that now breaks, right? So basically, if you have gas introspection as something you can use, it's just much easier to inadvertently write code that relies on specific relative gas prices being a specific way that then break. And so it's much harder to reason about, will anything on the chain break as we move to a different gas schedule, or even will just legacy contracts that want to be deployed that are not yet deployed be broken. And so basically the idea is more with EOF in the long run, once we are in a world where most contracts are EOF contracts, independent of whether or not these chains still support legacy, the risk of systems breaking goes further and further down over time, as most contracts basically are just by their design not possible to be vulnerable to this, if that makes sense.
I think it makes sense, especially if EOF Dominion is like years away. But then I think it means RIPs could have gas costs like up to implementers like rollups, or as you have mentioned, this idea of refund, which I'm not sure if someone refuted it or not. But we could just have our RIPs have like no gas in the specification. Is that what you mentioned, Scott?
Well, basically what I'm saying is there for now, just because we already have an RIP, so we have to kind of ship this now somehow. I think for now it makes sense to just stick with the default rule of everything has to be specified, including gas pricing. So for now, we have a specific gas price for the R1 precompile. If you want to support this precompile, you have to use that specific gas price. Otherwise, you can still ship it modified, but then ideally enter a different address. But it is definitely something I think that we should just look into, whether to what extent we can have flexibility there in the future, and in what form. But I think it's important to make the distinction between what to do right now if you want to ship something right now, and what is more of a research question for the IP process.
Yeah, I just wanted to say that maybe like one of the other options is Okay, so what we're now like basically discussing is whether or not to consider rollup supporting an RIP. Maybe it's like the same as with EVM. It's not like black and white. We can, besides just saying like in the repo where we say, okay, this RIP is supported by this and that rollup. Besides the name of the rollup, we can say type of support. Just reuse the same type system which Vitalik used for different ZK VMs and say, okay, if it supports absolutely the same interface, but it has the different gas costs, then we call it like type 3 or type 4 support. Like don't remember the number, but you get the idea. Maybe that would be a better approach.
Yeah, I personally would be hesitant to basically do this now. I think because it's harder once you do something like that to move back away from it. So I think I would just basically want to put that on the list of approaches to consider once we kind of try to move away from just you have to, or once we investigate moving away from you have to use the exact same gas pricing if you want to support a precompile. But that's basically I think the default state we are in today.
Like the reason why I bring it up is and like why I didn't bring it up like on the call about fees is because like ZK Sync era, it has inherently different fee model. Like it has like very different like gas pricing. Like so we didn't like even attempt to maintain the same gas costs in EVM. So we didn't have problems that some costs in EVM are bad for us. And so I think it would be like better and more representative for users if like yes, it was mentioned that gas costs are not the same, but it is mentioned that a certain precompile can be found there.
If I recall correctly, it even brought shortly after you launched, there was a project that I should say carelessly deployed on mainnet without testing and could not transfer because the gas stipend for transfers was not enough. So projects tend to have, even if it's the wrong thing to do, projects seem to have these unexpected dependencies on gas prices. Right? It's I don't remember which project it was, but you remember there was a project that broke this way.
Yeah, I remember, but maybe we should like drive forward to not encourage this dependence.
Yes, I'm 100% with you on that. We don't want to encourage it, but we also don't want to break it if we can avoid it.
But I mean, okay, so for old opcodes like a store and etc., changing behavior can be the dangerous as like in the and like in stipends for transfers as like the example which you brought up. But at least perhaps for new things we can explicitly say that okay, for this, like gas may or may not be supported. And as I already said, we can even add like a certain disclaimer that okay, here it is supported, but the gas pricing is different. So users are aware of that.
Yeah, you definitely have a point in that, of course. Yeah, basically projects that want to use an IP precompile or in the future whatever opcode or whatever other features we standardize via IPs, they will have to write their code more L2 aware anyway because it can only run on L2s. So if in that context we already give guidance for hey, you can't, on this L2 you can't rely on the same gas pricing or something that actually might help. And in general, it's good feedback because I was just didn't think of that in thinking about what counts and does not count as having supported a specific IP, that we just have to make to be aware that there are EVM systems that just don't use the mainnet gas pricing model at all. So we have to have some sort of system for what counts as support then in that context. And I guess just you have to use the exact same gas pricing of the IP does not work. I was not aware of that. So we'll look into that. Good feedback. Anything else on this point of pricing in general?
So something to keep in the back of your mind, probably not related to Precompile specifically, but when Verkle ships, gas storage charges, particularly around storage, are going to change in the way they work. So we are going to have multiple worlds where rollups will have the old world, unless they move to Verkle, which will be a big shift. but there'll be a time where they'll be on the old and the new. So there are going to be variations. Verkle is targeting 25 right now. It's considered the next merge. I think there's going to be a lot of effort to get it shipped.
Do we have a sense of if rollups should adopt Verkle trees as well?
Some rollups have already done their own thing with storage, like going to sparse Merkle. So I think diversity in storage tree implementations is going to be a feature of rollups. Some may go to Verkle, some may not.
And will it be visible from the applicative layer? Like the underlying, because you said you would change gas costs, so maybe then it would vary depending on the rollup and the storage layer.
Gas would probably be the only way to do it if you were to check the gas before and after a store and see if it matches the old schedules. But like I said, most auditors consider such testing an anti-pattern, and I question if there is a need for it in smart contracts. I don't see how knowing whether you're on Verkle or sparse or Patricia adds value to it, but I've been wrong before, so.
If I understand correctly, with Verkle, the issue will not be only storage in the sense of a store. It's also loading contracts, since you are paying per chunk. So some code, some things will unexpectedly cost more gas as they load more code.
I think the code loading overhead is probably going to be factored into the intrinsic. It might be figured into call as well. I think that's TBD.
Yeah.
And as it stands, UF will ship before or after Verkle, probably, in terms of priority?
If you know the answers to that, let us know, because that's what we're currently debating.
Okay.
So just on a little bit on timelines on all of this, as I just mentioned, like there is a lot of debating happening on the mainnet side, and like as we speak, we're trying to hash these things out. Things like Verkle, the large problem with them from an implementation standpoint is it basically blocks all features for probably at least a year and a half on the execution layer side, possibly more. And so it becomes very hard to make a case for it when we have to hold off on features. And so it needs just the decision needs to make sense in the greater context of what needs to be shipped. And so making a case for it also means making a case for not everything else for the next long time. And I think that's where the complexities are coming in. I think everyone wants Verkle. It's just a question of when exactly. And so I wouldn't immediately make, it's very hard to have insight into timelines here, and I wouldn't make any commitments or major plans based on presumed timelines quite yet. But I think in a few months' time, we'll have a lot more confidence in what the plans are here.
You said in order to ship Verkle, one should stop, like Ethereum should stop shipping features for 1.5 years, or right after Verkle ships, we need to hold features just to stabilize?
No, before. Just from a development standpoint, it's going to be very hard to get anything else done. I mean, there are arguments that we can do parallel work, but I think that only delays Verkle and the other things. So I think, like in a realistic world, given all the testing requirements and whatever that come along with a hard fork, if we do Verkle, we're going to block features shipping until Verkle, like from the point where we commit to do Verkle until Verkle is shipped. Most features will be blocked.
Okay.
I have one more topic on my kind of board draft for the agenda. Is there anything else on this point? Otherwise, I'd move on to that. Okay, right. So basically, the other question was, well, there was this proposal a while ago about progressive precompiles, but I would just want to take that as a general question of how do we make it easy for projects to write code across L2s that takes advantage of native implementations of features on the L2s where that is live, and easily supports them having some sort of fallback logic in case that is not. And ideally, of course, that would be forward compatible, where if it's deployed on a L2 that does not yet support something natively, that it automatically can switch over once that support is shipped there. Of course, the default, if we do nothing, could be that every app developer just has to manually write logic to check whether there is a precompile is live at a specific address, and if not, just themselves have to bring some alternative, just raw like Solidity implementation of that same feature. The question is, what kind of alternatives would we have? There is the lightweight approach of basically just having that in some sort of lightweight ERC feature. So where basically we just have some sort of standardized community maintained kind of equivalent implementation of IP precompiles and stuff like that people can use alternatively. And the question is there something more principled, more structured that we could do to do this? So just to briefly summarize the idea behind the progressive precompiles, that was basically saying that we could do it the other way around. We could have the Solidity implementation be part of the official flow. So basically, you could either just using normal, universal deployers. I understand they don't work on all chains, but on most chains, you could basically have like a common address that just the Solidity implementation lives at, and then you could manually go in, and as part of deploying the precompile, you could basically just swap out the Solidity code at that address for the native implementation. Of course, that's not the path we are on right now with our dedicated precompile address range. But I think it's important, kind of like as an idea that motivates this entire conversation. So I'm just wondering, do people have thoughts on how we can make support across multiple L2s that might or might not have shipped a specific feature yet as seamless as possible? Is this something that has come up yet for people?
I think even though every contract could check for the existence of a precompile it wants to use, maybe from Gaz's perspective, it might make sense to have one precompile that lets you query whether certain RIPs are or not supported on the current chain. So at least it's going to be one call. And then if your contract uses multiple things, you just you just check what you can or cannot use there. Does that make sense?
Yes, that seems like a good building block to have, and to me that seems just like a good candidate for an IP in itself, for a precompile like that.
Talking about RIPs, do we have a way to choose at which address the precompile should be deployed at? Because I noticed, for example, Aurora was using like a hash of some stuff, so it could not collide with L1. And then Ansgar, you mentioned before that we don't know which EIPs are going to reach mainnet and which are not. But you would ideally want to, like for those that will reach, you would want the same address as mainnet. And then for those that won't, then you want something that cannot collide. So is there standardization on this?
Right. So the status basically is that we talked with people on the CoreDev process side, so basically on the mainnet side about this. Initially, there were two ideas. One, to basically be opinionated about going into the same precompile range as mainnet, and basically just then asking mainnet to just skip the specific addresses used. But we ended up deciding that it would be easier to keep that separated. So of course, all the kind of the very lowest addresses are mainnet precompiles, and the idea now was to limit this to explicitly say that only the first 256 addresses on mainnet are reserved for precompiles, and then have the next, for now, 256 addresses above that be the dedicated L2 RIP, like RIP standardization precompile range. So that's kind of what we're going with so far. So the R1 7 to 12 IP also, as part of its specification, has a specific address that it is supposed to be deployed at, which is exactly number 256, because it's the first one in this IP range. So ideally, all layer 2s wanting to ship this should ship this at this address. Maybe this is a good question in general. Is there anyone on this call that knows about maybe an L2 that would not be able to ship it at that address?
And how, and then to ship at the specific RIP range, we need, like, who says, okay, this precompile is now accepted as a RIP range, like, is accepted? Have we standardized the voting process to accept one?
So very importantly, the IP process and the governance is like, this is all strictly opt-in. So just because we would accept an IP to or an IP precompile to that range would not mean that now all the L2s are accepted to ship it, right? So you can still then pick and choose which ones you want to support, and then otherwise you just skip those addresses. And of course, there's still a somewhat limited number of addresses, although that is artificial. We could go up a lot. There's a lot of addresses before we start to have to worry about collisions. I think for now the idea is that we want to be very permissive. So any RIP that comes with precompiles that reaches finalization status and can reserve an address. If it ever becomes a problem, if someone proposes an IP that wants to ship 20 precompiles, and maybe we have to revisit that decision. But for now, as long as it's not an issue, we want to be just permissive. But in general, this should just be part of the IP process, and we have to figure the details out.
Okay. But then I guess on your other point, which was like someone proposes a RIP with a precompile, and then in the meantime, someone proposes like a Yule or like a raw solidity implementation of it for those who haven't had time to implement it in their ZK secrets or something else. Then it might be prohibitively expensive, no? Like it will break the gas scheduling of someone might have had like low-level secrets that are somewhat not so expensive, and then the implementation of solidity is prohibitively expensive for the rollup itself, but then they have to respect the pricing maybe. I don't know, just thinking out loud.
Right, so any just solidity implementation would not benefit from special treatment and would not get special pricing. It's just a normal contract deployed somewhere, with just normal pricing that it has to pay. So that might mean it's prohibitively expensive to use for applications, right? Just because it might be much more inefficient. So I think, for example, with R1, I'm not sure if we have anyone on here that remembers the details, but I think it's something like 300,000 gas for even the most efficient implementations. Versus I think 3,000 or 4,000 that the native version would cost. So that might make it prohibitive for some applications to use. But it's not a problem for the rollup itself because it just charges for normal contract execution. And the only way in which this contract there might be an aspect that we don't just want to treat it normally, could be if we want to have a standardized address for the solidity implementation, and then we have these universal deployer systems that allow you on all unmodified EVM versions to deploy at the same address using create2 logic. But of course, there are some rollups, especially ZK rollups, that can't support this because they have the different hashing systems. So like, for example, I think ZK Sync is one of these examples. And so then the question is, do we just accept that on those rollups, we don't have the solidity implementation, equivalent solidity implementation of an precompile at the same address? Or would they maybe want to, with features they don't want to implement natively, just basically manually deploy a contract at an address that matches the standardization or something? That I think is one of these open questions of how to best approach this. So yeah, I think maybe at some point we can also have either breakout call or just some sort of separate effort where we kind of bring in people that are actively on the user side, kind of thinking about using, say, R1 or whatever other IPs we might be close to having final. Actually, Ulash, given that you're also kind of you're doubling in role here between the EAP author, but then you also have the Clave app. Do you have thoughts, like, do you have intentions of having? I know that you're already live now on networks that don't yet, of course, have the R1 precompile. How do you think in the long term about basically? I mean, I don't know whether you have thoughts, but about kind of the routing between the native implementations and just Solidity equivalents for R1.
I think the missing part might be that we cannot provide the same address in every rollup. For example, in the casing case, the crate 2 gives different address than the rest of the EVMs. So I feel like there is a lack of standardization for this kind of address selection.
Yeah, I think that is indeed a problem. So we have to figure out how to best do this. But maybe this is best left to the ERC side of things, right? Like in principle, the question here was more: is there something kind of from the base layer, from the EVM side that we could chip and we could change and we could specifically introduce this behavior that makes it easier for application developers? Otherwise, we can always just leave it to the ERC process to have some sort of standardized logic of how to do all of this kind of routing in the absence of specialized features. And I agree with you from the very beginning of this conversation that it would be worth looking into shipping a sort of precompile that exposes just information about what other features are live on any given chain.
Yeah, I think maybe like we mentioned that like some projects might want to deploy on like many L2s, but if like say 2 L2s have a specific RIP and it's priced low because they implemented it in their native ZK system, like maybe the project chose them for this specific feature because it's cheap, and this desire to standardize so that every rollup can have at least a Solidity implementation of it is maybe overkill, because the projects will have chosen them for this specific feature because it's cheap and available, and maybe the project will not want to go in like a rollup that has the Solidity version. Like we would have to validate the thesis that projects would want the precompile to be available or like RP on every chain, where even though on some chains it might be 20 times more expensive or 10 times more expensive. Maybe they don't actually want that. And the work to get a Solidity implementation audited and valid is a lot of work for something that is inherently, like some rollups have some niche use cases. I don't know.
Yeah, that's a good point. I think the reason why this came up in the past was that specifically for this first LP that we had as a specific case study, the R1 precompile, they have indeed big projects, and like largely all the projects that are also very interested in the precompile, a lot of them are already live on several L2s and are using just Solidity implementations for the equivalent functionality. But that could be an artifact of, I mean, A, maybe the specifics of R1 that is at least somewhat feasible to do that. And then B, also just the timeline that a lot of those projects got started before it was clear that there would be such an RIP. And so that just waiting was not an option. It could well be that for future changes that's a pretty uncommon situation, that there's even interest in that at all. And so you might be right that that could be worth just revisiting once we have more real world experience with other IPs in the future.
Have we done the decision of when to assign a new precompile address for a new precompile RIP? How many of the rollups should accept the implementation, or every RIP should get an next address?
Yeah, I think Elias also briefly brought that question up like a couple of minutes ago. I think for now, just because we don't yet have such a thing as before finalization, having layer 2 signal support or anything. So I think for now we want to just be permissive, and as long as there's a clear, not spam, good faith IP that moves to final, we would assign addresses in that range, because there's also no issue in just skipping some, and in principle the range can grow relatively large. If we ever see that this becomes too popular and just becomes a problem, then I think we have to have a more proper mechanism in place. But for now, I think the idea is to err on the side of being permissive and permissionless. It's fun. We always have a lot of people hop off the call on the hour mark, which makes sense. So it's always the important topic should always be in the first hour of any roll call session. That's good to know. But also I think we probably already, because those were the only topics that I had prepared to talk about. Of course, we have an open section in case there's anything else that hasn't come up yet. But otherwise, also I think it's perfectly fine if this call does not run up quite on the 90 minutes. So are there kind of any remaining topics to talk about now? Okay, yeah, then I think this is probably a good stopping point. I think this was helpful. Again, I think takeaway kind of is that we just have to really figure out the kind of the pricing situation. What does it mean to ship an RIP unmodified? Apparently, just enforcing the same gas price is not a viable option, because some EVM systems just have different pricing models. And then also, in more longer term, kind of seeing how these are used and then possibly adapting the system. But yeah, okay, that's end of that. Thanks everyone for showing up, and see you all next week. Will be a main roll call again. So then we will also have a brief retrospective of to what extent these breakout calls were useful and whether we want to keep having them in the future. So yeah, thanks everyone, and have a nice day.
Thank you.
See ya.
Bye.
Two. 5.